students, welcome to our channel. Our today's topic is motion in a straight line part 8. Here we are going to discuss how to choose a professional car driver who drives the car smoothly. That is, smooth driving is what? If he finds any obstacles, he should not put up sudden brakes. Okay, he should drive smoothly. So how to choose? So using physics, can we choose such a driver, professional driver? So here, what decides in choosing a driver is reaction time. It is reaction time. So you will know now. Now let us discuss what is reaction time and what is the linkage between our topic, that is we are in kinematics. This is motion in a straight line. What about this reaction time and what is our topic now? Yes, now we are in uniform acceleration case only. In previous 2-3 videos, we were doing problems involving uniform acceleration. So now we are continuing the same topic here. So here, in this case, now we are going to solve problems which involves a combo pack of uniform acceleration as well as uniform motion. So that is, in the journey, the body can have constant uniform motion, constant acceleration or constant deceleration, a mixture of all these things. So here, reaction time, the problems involving reaction time, they are having such a mixture of these things here. So first let us check what is reaction time. See, suppose this is the road here. A car is coming from somewhere else. It is coming from beyond, and when the car reaches point A, the driver sees an obstacle at a point C. Here obstacle is there. The driver sees the obstacle here. Point of, so we can call this one as the point of observation. So driver, when he reaches point A, he notices the obstacle at point C here. So immediately what happens? Immediately when he sees everybody who is driving a vehicle, immediately when they see obstacle, they try to apply brake. But here application of brake is, it is not that much. Immediately after observing the obstacle, we cannot immediately apply. Observation and application of brake cannot take place simultaneously. There is some time gap. So noticing, observing the obstacle and applying the brake, between these two things there is some time lapse. That time lapse is called as reaction time. The time lapse is called as reaction time. If reaction time is more, the driver is bad. If reaction time is less, the driver is good. So I have to choose a driver whose reaction time is less. Okay. See here, suppose when the driver observes the obstacle at point C, when he is at point A, then what happens? His brain has to send signals to his foot, because foot only it presses the brake, no? So the foot has to get signals from the brain. So the signals from the brain to reach the foot, there will be some time lapse. So that time lapse is called as reaction time. So this person immediately he tries to apply brakes at this position, but he cannot apply because his foot has not got information. So what happens? The car goes on like this, and this driver would be able to press the brakes when he reaches these points. Press the brakes here. So at B he pressed the brakes. At A he observed the obstacle. At B only he could be able to press the brakes. So the time, for suppose if the time here is T1 and here the time is T2, therefore what is reaction time here? Reaction time is T2 minus T1. Reaction time is T2 minus T1. Okay, let us learn some more things here about the motion of the car, because our chapter is motion in a straight line. So let us consider about here different parts of journey are there. Let us consider in which part of journey the car is having which type of motion. So in which part of journey the car is having which type of motion. So from beyond to point A, what type of motion? Suppose the car is moving with a constant velocity, v equal to constant. At A, what is the velocity? This is the same velocity. Before A, what is the velocity? At A also the same velocity. From A to B, what is there any change in the motion of the car? No change, because brakes are not applied. Here from A to B, velocity will be constant, v equal to constant. Here from A to B, velocity is constant. Then after B, what happens? So he presses the brakes at point B. So after B, what happens? The car undergoes a deceleration. Deceleration means velocity decreases with the time. The rate of decrease of velocity is called as deceleration. Here velocity starts decreasing starting from point B. Decreases. At C, obstacle is there. At least the driver has to stop the car touching the obstacle. That is the limit there. Just it has worst thing is that it has to just touch and stop, so that the car does not take even a small minute damage. Okay, that is the limit here. Okay, so if he crashes, what happens? If he could not stop at this point, see, he is worst driver. If he stops the car just touching this obstacle, but there is no even minute damage to the car, he is a bad driver. He is a bad driver, because he should have stopped that one before, long before the car reaches the obstacle. So who would be a good driver here? Who stops the car carefully at a sufficiently good distance from the obstacle. Okay, everybody prefers such type of drivers. They are good drivers. Okay, now, so here beyond A, let us suppose that the car is moving with constant velocity from A to B, because at A he noticed the obstacle. He could not apply brakes at point A here. So the car continues to move with constant velocity till the car reaches point B here. At B only he could be able to apply the brakes. So from B to C, what type of motion it is having? A deceleration. So here beyond A, what type of motion? Beyond A, uniform motion. And A to B also it is uniform motion. And here it is B to C, it is deceleration. Let us see what happens. Let us see, it stops. So this is all about the reaction time. So now let us solve a problem based on this reaction time. So in this case, what are involving regarding motion? See, uniform motion as well as deceleration. So a package of uniform motion as well as accelerated motion. Okay, deceleration and acceleration, both of them are same only. In one case velocity increases, in another case velocity decreases. Okay, right now. So now let us check the problem. A car is moving with constant speed 50 meters per second. Suddenly the driver sees an obstruction on the road and it takes 0.40 seconds to apply the brake. The brake causes a deceleration of 5 meters per second square. Find the distance traveled by the car before it stops. See here. So first let us do the problem systematically, so that there will not be any confusion here. So to avoid confusion, so we should solve a problem systematically. So let us take given quantities here. What are given quantities? Always we should have an idea of given quantities. The car is moving with constant speed. So initial speed, it is 15 meters per second. Suddenly the driver sees an obstruction on the road and takes 0.40 seconds. What is reaction time here? Reaction time T0. Let us suppose reaction time T0 equal to 0.4 seconds. So reaction time T0 equal to 0.4 seconds. the brake causes a deceleration. So let me write A equal to, since it is deceleration, let us write minus 5 meter per second square. Okay, what should we find? We should find S total distance traveled by the car before it comes to rest. From when to when? By the time, so here we have to find the total distance when the driver notices or observes the obstacle from there to finally where the car stops. So till then. So to find, what we have to find here? We have to find S total distance equal to how much? Okay, we have taken given quantities, we have taken quantity, we are aware of the quantity to be found here. Now let us draw the diagram. Suppose, so where does our problem starts here? The car is coming from somewhere else. It is not a part of our problem. So what is the starting point of our problem? When the driver sees the obstruction. Suppose the car is coming from beyond, and let us suppose that the driver sees the obstruction when he is at this point here. Let this be the obstruction or obstacle here. This is point C. So here it is obstacle. So this is a point of observation. Point of observation. So what happens? What do you know previously? Yes, he observes here, but he could not apply brakes at this point itself. Suppose, let us suppose that he could apply brakes when he reaches this point B. See, what is the point B here? It is a point where the driver applied brakes. So this is the case. Okay. So now, so A to B, what type of motion this one? This is the uniform motion. Constant velocity, we call it as uniform motion. And from B to C, what type of motion? It is a deceleration. It is a deceleration. Okay? Right now. So, the car, it has to stop at point C. At least. It is a boundary condition. Okay? It is good if he stopped well before point C. So the boundary condition is that if he is a bad driver, he can be bad up to here only. He can just touch this point C without any damage to the car. So okay. So that is the boundary condition. So let us take the values here. What are the values here? So initial velocity when so beyond this point A, the car is moving with velocity 15 meters per second. So when he observes the obstacle at this point here also, velocity u equal to 15 meters per second only. And next, at point B, what is the velocity here? Here also velocity is same, u equal to 15 meters per second, because till he reaches point B, he could not apply brakes here. So from A to B, what type of motion? It moves with the same 15 meters per second speed only till it reaches point B. And when the car reaches point B, then he applied brakes here. So now what happens? The velocity of the car goes on decreasing, so we call it as a deceleration. So finally it stops here, let us suppose. So here what is the velocity at this position? Here v equal to 0. So what is the deceleration here? Here from B to C, A equal to minus 5 meter per second square. So if you are writing between any 2 points, means suppose I am writing A equal to minus 5 meter per second square between these 2 points, what does it mean? This acceleration is from point B to point C. It belongs to these 2 points of motion, right? Yes. Now let us solve this problem. So we are aware what else is there in this problem? Uniform motion and deceleration motion. It's a combo pack of these two things here. So now what is the reaction time here from point A to point B? The time is T0. It is the reaction time here. So what is the T0 here? T0 is the reaction time. That is the time between the observation of the obstacle and application of brakes. So obstacle is observed when he is at point A and brakes were applied and he reaches point B. So the time between these 2 points, we mentioned this one as T0. This is reaction time. This is equal to how much? This is equal to 0.4 seconds. Reaction time equal to 0.4 seconds. So now we have to find total distance here. So let us suppose that here the distance is S1 for this part of journey, and here the distance is S2 for this part of journey. So what is total distance now? We have to find total distance. S total equal to S1 plus S2. This is equal to how much? Now let us solve. So let us first consider A to B part of journey. A to B part of journey. A to B part of journey, it is a uniform motion. So there is no choice. We are having only one formula. The body moves with uniform motion. So what is that one? S equal to Vt. Distance equal to speed into time, or displacement equal to velocity into time. Here, since it is a motion in a straight line in one direction, distance and displacement, speed and velocity, both of them are same. No need to bother. There is no chance for any confusion here. So watch my previous videos. There I explained. I did some problems explaining these things there. Okay. Right now. So S equal to Vt. So you have to find this distance, that is S1. So let us apply this equation for this part of journey A to B. See what we are considering here? We are considering A to B. So we are considering only this part of motion here. In this entire journey, we are considering only A to B part of journey. What type of motion it is? We should know what type of motion, because we have to apply kinematic equations. So if it is uniform motion, we are having only this equation. If it is uniform accelerated motion, then we have to use the set of kinematic equations. S equal to ut plus half v square, v equal to u plus at, v square equal to u square plus 2s. All these they are meant for bodies moving with a constant acceleration, right? Okay. So here, since this is uniform motion, we are having only one equation, that is S equal to Vt here. So applying for this part of problem, what is this? S equal to S1 equal to what is V? V equal to 15 meters per second. So this is equal to 15 into what is T here? This time is reaction time. This is equal to 0.4. So this is equal to how much? 6 meters. So S1 equal to how much? 6 meters. Now let us do that one. S2 let us find. Now to find S2, which part of journey we have to consider here? B to C part of journey. B to C part of journey. So what type of motion it is having? It is a uniform motion or accelerated motion? Accelerated motion. What type of acceleration? Uniform acceleration. It is okay. It's a deceleration. Deceleration and acceleration, both of them are same. Acceleration means rate of increase of velocity. Deceleration means rate of decrease of velocity. Okay. Deceleration is a negative of acceleration. We can call it as, okay, right. So B to C, what type of motion it is having? It is a uniform acceleration. We can call it as acceleration. We know velocity at B. What is velocity at B? See here. At B, velocity u equal to 15 meters per second, because B is the starting point. In the part of BC part of journey, we are considering BC part of journey. What does it mean? Here in this case, now in our case, B is initial point and C is final point. That's all. So velocity at initial point is known as initial velocity. Therefore, what is u here? U equal to 15 meters per second. And what is final velocity? It is 0. It is 0 meters per second. So when the particle reaches the point C, it is coming to rest. So it is coming to stop. Therefore, V equal to 0 meters per second. So we are having uv, as well as we are having deceleration A equal to minus 5 meter per second square. We are having this one. So we have to find S2 equal to how much? It is very clear. So what is the equation we have to use here? V square equal to u square plus 2as. So here v square 0 equal to what is u square? 15 square plus 2 into what is acceleration? Minus 5. Should be careful with the minus sign here. If it is acceleration, you should take plus. If it is a deceleration, you should put minus here, right? So what is the displacement? It is S2. Now 0 equal to 225 minus 10 S2. So this implies S2 equal to 222.5 meters. So what is total distance? S equal to S1 plus S2. So this is equal to 22.5 plus 6. So this is equal to 28.5 meters. This is the total distance. So So it's very simple. So just you should know what is the reaction time. So if such type of problems, students generally they face problem regarding reaction time only. So you should know clearly what is reaction time. So after that, the problem is as usual as we did before, right? Let's meet with our next topic, that is what is moving under